Welcome to the solutions video for IXL Grade 12 Skill G.11 Exponential Growth and Decay Word Problems. If the number of bacteria in a colony doubles every 16 minutes and there is currently a population of 5 bacteria, what will the population be 48 minutes from now? So we know that there are currently 5 bacteria. So with any exponential growth, that initial constant is where it begins, because when we have time 0, our exponential is going to be 1. So the amount we have over time is that initial 5. It says doubles, so our exponential is 2. It's a 16-minute doubling time, 48 minutes later. So that's 5 times 2 cubed, 5 times 8, which is 40. So there'll be 40 bacteria 48 minutes from now. Now, how much of a radioactive kind of europium will be left after 18 years? If you start with 64 grams and the half-life is 9 years. So we'll use the same sort of pattern. We start with 64 years. The half-life is when we have half the material left. We have 18 years elapsed, and the half-life is 9 years. So this is 64 times 1/2 squared, and 64 over 4 is 16. So we will have approximately 16 grams of europium left. You have 768 grams of a radioactive kind of tungsten. If its half-life is 1 day, how much will be left after 4 days? So we have 4 periods of 1/2. 2 exponent 4 is 16. So we have 768 divided by 16, which is 48 grams. How much of a radioactive kind of strontium will be left after 130 days? If you start with 872 grams and the half-life is 65. Well, for this, we have 2 half-lives, because it's 130 days total at 65 days. 130 over 65 is 2. So 2 half-lives means we're down to a quarter of the original. 872 divided by 4 is 218. Now, average healthcare premiums have been increasing at a rate of 5%. If an average family's premiums are $13,000 this year, what will they be in 6 years? Oh, am I glad we don't live in this system. Anyway, we have to watch rates of increase, because we're not just dealing with a 5% here. That means after each doubling period, or after each period of growth, we have 105% of what we used to have before. So our initial rate was 13,000. We have 1.05, which is 105% as a decimal. And it's 5% per year. We are looking at 6 years. So we have that to the exponent 6. We're about $17,421.24 after rounding to the nearest cent as per the question. Now, the half-life of radioactive kind of iron is 3 years. We start with 5,248 grams of it. How much will be left after 12 years? That is 4 half-lives. 2 exponent 4 is 16. So 5,248 divided by 16 is 328 grams. Oakdale University charges $51,000 for tuition. If they raise their tuition by 5% each year, how much will the tuition be in 4 years? So this is like the health premiums question. 51,000 times 1.05 to the exponent 4 is $61,990.82. So, a Nautilus shell is made up of many chambers, each chamber roughly 5% larger than the previous one. Assuming a Nautilus creates a new chamber every year, and this year's chamber has a volume of 870 microliters, how large will the chamber created in 14 years be? So this is 870 times 1.05 exponent 14. Which is 1,722 decimal, and the 540492 rounds 2.5. So if a city with a population of 172,000 doubles every 91 years, what will the population be 455 years from now? That is 5 doubling periods, so that's 2 exponent 5. So that's 5,504,000 people. It's a rapidly growing city. The cup of hot water is left out to cool. The water is currently 57 degrees above room temperature. If the heat difference decreases by 5% every minute, what will the difference be in 18 minutes? So our exponential here, if it's decreasing by 5%, that means we have 95%. So writing this down, this is a case where the initial is 57 degrees, and we are at 0.95, and it drops each minute, and I believe we have 18 minutes. Yes. So it's this exponent 18 will give us our answer. In degrees Celsius, which is 22.6 rounded to the nearest tenth. So yes, and that's the difference above room temperature, notice, because when something is cooling or heating, it's approaching room temperature. So this is the difference in degrees Celsius, not the absolute temperature. The rabbit population in Union County, which is currently at 7,040 rabbits, is increasing by 10% each year. Percent increase, again, we're adding to 100, writing it as a percent. So we have 7,040 times 1.1 exponent 12, because 1.1 represents 110%. So that's 220,995 after rounding. It's 9453577. Now, you have 81,672 grams of a radioactive kind of promethium. If the half-life is 41 days, how much are we left after 82 days? That is 2 half-lives. So we're going to be down to a quarter of the original. 20,418 grams. A union has successfully negotiated for its members to get 5% raises annually. So that's a current salary of $44,750. What will the salary be in 8 years? That's 1.05 exponent 8. So that's $66,116.13. Now, you have 141,008 grams of a radioactive kind of nickel. If the half-life is 96 years, how much will be left after 288 years? Well, 288 divided by 96 is 3. So 1/2 exponent 3 is 1/8. So we take our 141,008 and divide it by 8, and we get 17,626. Now, a blight is spreading in a banana plantation. Currently, 280 banana plants are infected. If the disease is spreading at a rate of 5% each year, how many plants will be infected in 5 years? So that's 280 times 1.05 exponent 5, or 357 after rounding. We you'd have that 0.3588375 after that. If the number of bacteria in a colony doubles every 459 hours, and there's currently a population of 156,200 bacteria, what will the population be 918 hours from now? Well, that is 2 doubling periods. So if it doubles twice, we're multiplying by 2 twice, or by 4. Gets us to 624,800. A farmer feeds a cow 6,277 milligrams of an antibiotic. Every hour, 27% of the drug breaks down in the cow's body. How much will be left in 2 hours? So after each hour, we have 73% of the original remaining. And we always have to represent these as relative to the original. So when we're looking at percent decreases, it's 100 minus the 27. So this is 6277 times 0.73, which is raised to the exponent 2. So that's 3,345 milligrams after rounding. A glass of cold milk is sitting on the counter, warming up to room temperature. Currently, the milk is 5 degrees below room temperature. However, that difference is shrinking by 6% every minute. What will the temperature difference be in 17 minutes? So every minute, we are approaching that. So this is something where technically we should have a negative exponent coming in. So if we're currently at 5 degrees below, but this should be, I think, a negative 5. And then we are growing by 6% every minute. So we should be representing this as a negative 5 times 0.94. Because that represents a temperature steadily approaching the room temperature but not hitting it. If we use a positive number here and an exponential of 1.06, then we're growing exponentially, and we will not have that asymptote that we are looking for. We need a horizontal asymptote at 0. So this is the one we are looking for, and we want the value when x equals 17, so we'll just set up. So it is now 1.746 degrees away. So 1.7 degrees from room temperature. So that one is a little bit tricky in the initial setup, because we needed to make sure that we were approaching room temperature as a horizontal asymptote. Now, Steve owns a painting that is valued at $42,408. If the value of the artwork increases by 10% each year, how much will it be worth in 9 years? That's 42,408 times 1.1 exponent 9. So that's 5.85. That was a worthwhile investment if you've got 42 grand to spend. Here we go. Challenge zone. A publishing industry report predicts that magazine subscriptions will drop by 9% each year. If this prediction is correct, then how many subscribers of a magazine with 70,977 subscribers have in 10 years? So each year it's down to 0.91% of what it used to have. We raise that to exponent 10. And it's 27640. Now, a newly launched clothing line is rapidly increasing in popularity. Every month, 14% more items of clothing are sold. If 54,332 items are sold this month, how many will be sold in 3 months? That's 54,332 times 1.14 exponent 3, or rounded to the nearest whole number, 80,495 items. A cliff overlooking Fairview Lake is experiencing erosion, losing elevation at a rate of 3% every millennium. The cliff's current elevation, is 1,400 meters. What will its elevation? I can't speak today. What will its elevation be in 9 millennia? So it's going to be 1,400 times 0.97 exponent 9. So that is 1,064. Now, rats have become a nuisance in Greenpoint. Efforts to control the rat population have led to the rat population declining 9% every year. If the town has 16,721 rats, how many rats will there be in 8 years? That's 0.91 exponent 8, or 7,863. Now, we are almost done. A glass of cold milk is sitting on the counter warming up to room temperature. Currently it's 5 degrees below room temperature. However, that difference is shrinking by 9.7% every minute. What will the temperature difference be in 17 minutes? This is almost the same as this. It's just a different base. So that 9.7% deduction gives us a 90.3% difference. So now we are 0.882 degrees away, or 0.9. Okay, so that concludes this assignment, and it also earns this prize down here, a spinning wheel for mastering 5 exponential and logarithmic function skills.